Question number 7. This question is of integration. Part A. Use the substitution u is equal to cos x to show that integration of sin 2x into e power 2x 2 cos x sin 2x into e power 2 cos x integration with the limit 0 to pi is equal to minus 1 to 1 is the limit 2u e power 2u with respect to u. This is integration by substitution. Substitution is given. We will use u in place of cos x in the left hand side to show the right hand side. This method is also called changing the variable method. 0 to pi sin 2x e power 2 cos x with respect to x. These are two functions, product of two functions. Substitution is u is equal to cos x. This is substitution u is equal to cos x. Now first of all we will use here a double angle formula. Sin 2x is 2 sin x cos x, 2 sin x cos x into e power 2 cos x with respect to x. Limit will be changed, so we are not writing here the limit. Just now we will adjust these functions, so we may change all the trigonometric functions into u. We can write 2 outside the integration sign. Sin x cos x e power 2 cos x with respect to x. Now we can write 2 cos x sin x with respect to x. First we write it as from here we are differentiating u with respect to x. Now this becomes du over d x is equal to minus sin x. From here du is equal to minus sin x dx by cross multiplying. So we can write du in place of minus sin x dx. So we are multiplying and multiply to bring here a sign negative. We will write it as negative sign, negative sign, negative, negative become positive. So no change in the function. Now we will write it negative 2. First we write cos x e power 2 cos x minus sin x dx. Now in place of minus sin x dx we uh, can write du, because du is equal to minus sin x dx. This becomes du, and putting, because substitution is u is equal to cos x, in place of cos x we will put u. This becomes minus 2 u minus 2. We can write this minus here, and 2, because we have to show that 2 and 2u e power 2u. So we can write 2u, in place of x we are putting u e 2u, or this is minus sin x dx becomes du. So we can write du. Now the limit will also be changed according to the given substitution. When the variable is x, the limit is 0 to pi. Now the variable has been changed, so we will change the limit also. This is a method to change the limit. We make this table. When x limit is 0 to pi, now the variable is u. Now we use the substitution. When we put x is equal to 0, then cos 0 becomes 1. Cos 0, 1. U will be, when x is equal to 0, u is equal to 1. When x is equal to pi, cos pi, that is value of cos pi is negative 1. So we are writing here negative 1. Now we will take this limit 1 to negative 1. So we are writing here limit negative 1, 1 to lower limit is 1, upper limit is negative 1. Now there is a rule, important rule, when limit is a to b. If we interchange this limit, then we will write negative b to a. If we swap the limit, the integral will become negative. This concept we are using here. This becomes, then this negative sign become positive and limit will be changed. So we get finally minus 1 to 1 limit 2u e power 2u with respect to u. We have shown this. This is the answer. The next part of this question, part B, hence find the exact value of with the limit 0 to pi sine 2x e power 2 cos x with respect to x. Now we are not using this integral, but we use the other form of the integral which we have just shown. We integrate this and find the exact value. So negative 1 to 1 to u e power 2u with respect to u. Now here we will use integration by parts. This is the first function. We will take this function. First we write it as 2, bring 2 outside the integration sign, minus 1 to 1 limit u e 2u with respect to u. Integration by parts, we are taking this u as first function, e power 2u that is second function. This is formula of integration by parts. We will use here the concept of integration by parts. This is formula of integration by parts. Let there are two functions, function 1 and function 2. Integration will be first function as such into integration of second function minus sign of integration. We again write here the integration of second function multiplied by derivative of first function. We will use here this formula of integration by parts. So 2 within bracket first function is u, integration of second function e2u over 2 minus integration sign e2u over 2 derivative of first function that is 1, differentiation of u with respect to u is 1 with respect to u. Now we will take the integration of this. First we adjust it to u e power 2u over 2 minus 1 over 2 integration of e2u with respect to u. Now we integrate e power 2u minus 1 over 2 integration of e2u over 2. Now we simplify it. This 2 outside the bracket will be multiplied by these two terms. This becomes u e power 2u minus, we are simplifying it, multiplying by 2, we get here e 2u over 2. Now we apply the limits. Lower limit minus 1, upper limit 1. Using the limits, upper limit in place of x, first in place of u, first we will put 1 This becomes 1 e square minus e square over 2 upper limit minus minus 1 e power negative 2 minus e power negative 2 over 2. Now we will simplify this and give the answer in exact form. E square minus e square over 2, by taking LCM we can write it as e square over 2 plus, we are taking minus common because both terms are with my negative sign, negative and negative, positive. This becomes, this sign become positive. 1 over e square plus 1 over 2 e square. Now these are two fractions. LCM is 2 e square. Applying the LCM process, we can write it as e square over 2 plus 2 plus 1 over 2 e square over 2 plus 3 over 2 e square. Once again we are taking LCM. 2 e square is the LCM of these two fractions. E4 plus 3. This is the answer, but we can further simplify it. 2 e square can divide each term of the numerator, so we will write it finally 1 over 2 e square e4 over 2 e square, that is 1 over 2 e square. Now 3 over 2 e square, that is e power negative 2. This is the final answer in exact form.